What does it look like to realize the value of digital twin? While the concept of digital twin, or a digital replica of a physical asset, has been around for years, its adoption into industry has taken on a new level of importance due to the manufacturing limitations of COVID-19. Good morning, everyone. I'm Tom Kelly, Automation Alley Executive Director and CEO, and welcome to the final episode of our weekly live stream series, Industry 4.0 in Focus. Today, I'm pleased to be joined by engineering experts from Lawrence Technological University and Oakland University as we break down digital twins and how they are transforming the manufacturing sector. With me here this morning is Ross Sanders. He's the Manager of Corporate Partnerships at LTU. Dr. AMHUB Ali, he's the Associate Professor at LTU, and Robert Van Til, the Chair and Professor of Lean Studies in the Industrial and Systems Engineering Department at Oakland University. Good morning, everybody.
Morning.
Morning.
So for our live stream viewers, just a quick note before I open up the this wrestling match we're going to have around digital twin. I'm sure we're going to have a lively discussion. If you're a live stream viewer and you want to ask a question, use the Q&A function below. Click on that, ask a question. Might be up top, might be down below, wherever my finger is pointing, look, and you might find it. But that's how you interact with us. We're happy to take your questions. But first, I'm going to start with a broad question about what is digital twin and how are they being used today in the manufacturing industry. Let's start with you, Ross.
Sure. So the definition I like to use is a digital twin is a digital replica of a physical product, process, or system. And what it allows a user to do is experiment with the digital file before making changes in a physical environment, which leads to better decisions, which leads to cost savings, time savings, better quality. You know, there's a lot of different uses for digital twins. I mean, you've got digital twins of assembly lines now that allow users to experiment with different configurations of floor layouts, equipment configurations, staffing configurations before making changes to the physical line, which, you know, has huge benefits. You've got digital twins of assembly line machinery now, which allow users to better predict when machines need maintenance, which leads to less downtime. And now you've got, you've got control engineers who need to respond to emergencies can now be trained in a digital world, so they're better prepared to respond in a physical world. So, a lot of different uses, a lot of different applications.
Robert, you agree with that? Digital twin, did Ross leave anything out?
Sure, it's used not only to build a twin of an existing system and to understand it, to improve it, and do what-if analysis, but also obviously up front in the design. The twin is often built first to actually design the system. And if you have good data, you can do some nice analysis before you start spending money on parts where the costs really start going up when you get physical. You can do a lot of design analysis, and with good data available now. Another area you get into is areas like ergonomics even. Where you can use a digital twin of a human in a physical environment and analyze a work task. One of the OEMs started doing that a few years back, and their workers' compensation costs have plummeted within a few years.
Amazing. So AMHUB, we talked about some of the benefits. Ross mentioned some of the benefits. Robert mentioned some of the benefits. What are you seeing as you work with industry and you're out, working with your project engineers out in the field? What are you seeing in terms of digital twin that excites you, that says, boy, we're really onto something this time around?
Yeah, thank you, Tom. So I can say that people are trying to use real-time data-enabled systems so they can do the reasoning, learning, or dynamically adjust their systems for the productivity improvement, bottleneck improvement. And it would be like kind of an integrated virtual and the live situation together. So it is not just standalone design and standalone manufacturing. So how they're combining, and they want to emphasize that with the smart integration kind of thing, so they can see as a more competitive advantage part of the whole industry.
Excellent, excellent. So why all of a sudden, and this is open to all of you, and we can start a discussion here. Why all of a sudden is it here? I mean, digital design, digital twin, I guess that's the current buzzword, but it's kind of been around for a while. Why all of a sudden is it here? Whereas before it was always this thing over the hill and around the bend, but not quite here.
So I'll take it on this one,
Yeah.
you could see that our first industry revolution, second industry revolution, third industry revolution, what happened when we had the CNC, one country or one group of the country leading, and then when automation came, then industry leadership changed. Now we have the smart technologies, disruptive technologies, and with this technology, many companies are closing and many new companies are popping up. So who would be the winner in this competitive game? And that's why all companies are chasing for it. So who should be the winner or who should be the industry leader? And because continuously industry is changing with these smart technologies, that's the reason every company is jumping on to see who could be taking lead on and capture the market.
Tom, I can chime in on that too if you want. You know, the only other thing I would add is just you've got the falling prices of these IoT sensors. And so now the physical products are armed with these IoT sensors, which are feeding data to the digital twins to make the digital twins that much more powerful. And so the falling prices of these IoT sensors are really making things, making the digital twin that much more powerful and that much more attractive out in the marketplace. And you know, there's advancements in other technologies too, but the falling prices of IoT sensors are really, I think, driving a lot of the adoption.
Yeah, it's Internet of Things, IoT. The data that you could never get in the resolution you needed is now available. We did a project back in the mid 90s with an OEM modeling a framing line in an assembly plant. They were having issues and built a digital twin before that name, you know, 20 years before that name came out. And when we built the model, the tool was there. We built the model using their data, and it was, you know, 50% of what the real system was doing. You start looking at it, and they had been collecting some data, but it's just not good data. Well, how do we get the right data? Take a stopwatch, go out and spend 2 weeks on the line on every station. You just couldn't get cost-effective data.
So we're getting a lot of good questions coming in. I'll intermix them. So we got a question from Suresh, a question from Jeffrey, and an anonymous attendee. I'm going to take them in reverse order because I think they fit better that way. So Jeffrey Sage asked, so OEMs have been performing digital crash simulations for over 20 years. What's the difference we're talking about now in this form? And I bet all of you have a great answer for that. So chime in, whoever wants to start. We've been doing it forever, guys. Why is this suddenly different?
He's right. The tools are there. It's the data. Again, a crash simulation, you spend a lot of time, mount a lot of sensors, you collect a lot of data, and you do it once or twice. On a manufacturing system, you just didn't have that sensor. We didn't have those sensors. You didn't have all that data. There was tools to model it, discrete event simulation tools, a lot of them. But the data to make them realistic, a true digital twin, not just an estimation, wasn't there.
Yeah, and just kind of on top of that, you know, Tom, now, you know, smaller companies can use this because just as we were discussing the falling prices of IoT sensors and the advancements in other technologies, you know, smaller companies can now use it. So not in this year's report, but in last year's report, we featured a very small manufacturer who was designing a product for a customer. And so she built an augmented reality model to demonstrate to the customer what she was doing and how to design it. And
Wow.
so they made design changes on the fly. So it's not just for big companies anymore. It's, you know, it can be for smaller companies. And I think it's a lot of it is due to the falling prices and the advancements in the technologies.
So is it safe to say, and I know Ahad is going to chime in here in a minute, is it safe to say that it's the whole cost of the system? You know, to run a crash test, it would not be unrealistic a couple of years ago to spend tens of millions of dollars to run that crash test, right? And now that kind of sensor technology, it's so inexpensive, anybody can generate tons of data and do simulations on it. Is that a fair assessment of what I'm hearing?
So not just simulation, because when you are collecting the data, because data analytics got popular and you have a lot of data mining technologies, and that benefit factory floor is not using from crash analysis and how that information can be used for design, can be used for the manufacturing, prototype, and even in the further in the while you are using the product, and then that integration part is missing. All are having as a kind of silos, and this digital twin and this integrated data technologies, IoT will give the kind of integrated system where industry can see better benefit.
One interesting point on the crash simulation is that's a that is a system that has physics behind it.
Mm-hmm.
The physics of, you know, how you bend metal, how you crash, and Newton's law, and all those physics are there. In a manufacturing system, there is no physics. It's randomness, it's people, it's, you know, it's crazy. And that's where the data becomes important, because there is not a physics to build the model off of.
Right. So I have a question back to our anonymous attendee. By the way, anonymous attends almost all our sessions, so thank you for that. Very busy person, very busy. So they asked, how do traditional simulation software tools differ or compare to the definitions provided for digital twins? I think there's a confusion that says, look, there's all these simulation tools out there, and you're talking about digital twin. How do you reconcile those?
So I'd like to say that suppose we have in the lab environment, we have a Siemens electromagnetic assembly line. So we have the real assembly line with the automation. Now we'd like to create exactly similar situation, interact with the real life situation and with the virtual situation, and it will help each other try to perform better, predict better. So it would be an integrated system. But previously simulation is standalone. You enter the data, and then based on the result, you go and change the manufacturing system. Now you have that virtual system. You can integrate that simulation like to control the line. So that kind of thing is totally different compared to like static simulation.
It's the quality of the simulation. I mean, he's totally correct. The tools have been around a long time. They're constantly improving. They've been around a long time. But as I said before, with the data now, instead of a rough estimation model, the model can be a digital twin of the actual systems. You can build a much better model that twins the system. And now that term is coming popular because of that.
Just on top of that, you know, Tom, there's an example of a sensor on an automobile which was feeding the designer of the airbag system who was working off of a digital twin. So it's feeding data to the designer who's developing a digital twin of the airbag system and designing it on the fly. So it's a perfect example of getting access to the data and making the tool that much more powerful.
Excellent, excellent. So, so with that in mind, and I think what I heard was, look, the simulation tools, they are digital twin. They're getting cheaper. The sensors are getting cheaper. The ability to collect and store data is getting cheaper. As you create this system of real-time interaction, feedback back and forth, that's what we're talking about. Everything's stitched together in a nice bow. So Scott Phillips asked a question. What digital twin use case would you recommend for a small metal fabrication shop to get started? This is a great question because it leads to the majority of our members, guys, as you know, are small. Hundreds and hundreds and hundreds of members are small, and they think digital twin sounds complicated, complex, scary, technical. I mean, all the things that they would say, I don't have time for this. What do you guys say to that? How would you get started if you're a little guy?
So little guys, I'd say that I'm using simulation from 1997. From system modeling, they had Arena, then Rockwell Automation bought it. Then I use PlantSim, ProModel, ExtendSim, all the simulation tool. Now all the simulation package now trying to integrate with the real life situation for small packages. And also I did many simulation projects with those small companies. I would say you can try with any of the software provider, see first how the simulation is working for your plant, will serve your purpose, and then you can try to build the digital system, a twin system. First try to see that, validate your simulation model and see how that simulation model can be integrated with the real life situation, and that's the will get benefit. And those kind of, for small packages, for those kind of software provider, all are similar software provider, they can provide initial tools. So you can try, and then some student can help and try to do the assessment, or it could be a pilot project. Before going for full scale, just make sure this is the right tool, and that could add value to the company.
And Tom, I just want to chime in. I don't know if people have access to the 2019 report, but a whole section of the 2019 report on digital twins was specifically designed for the small manufacturers and how they can get started. So there's several profiles in there that folks can.
Yeah, it's on, great point, Ross. It's on our website. If anybody has trouble finding it or downloading it, this year's or last year's, let me know. Reach out to me directly. Anybody on our staff, we'll get it for everybody, but for sure.
You know, you have to kind of understand what you want to solve. I guess your first point is find a pain point and focus on that. Don't go in and think I'm going to build a complete digital twin of my whole business and everything's going to be hunky-dory, because you're not. There's this bottleneck. There's something that is causing flow issues, or can't meet demand or capacity, and we need to kind of build a little model of that to understand how it works. And so you find some little pain point and focus on building a twin of that pain point, verifying it and running it. You can try working with the university. I'll plug the university. Sometimes they will work with small places. You might be able to get a small student project. Of course, you're not bringing in high-level experts. You're bringing in students who are learning the tools at the same time, but that can help you sometimes kind of get a feel for what's going on and get started. And some university classes are worthwhile.
So guys, this leads to, so you're a small metal fabrication shop. You may want to use digital twin to say, look, if I run a design software on the front end of the part I'm fabricating, and I run a lightweighting simulation on that, I also need to be able to model, can I actually make it once the computer says I can lightweight it? I mean, there's one aspect, say, oh, I'll just 3D print it, but that's not available to most people, and it's not cost effective on large production. But can I machine it on a 6-axis CNC machine? That would that be appropriate? Am I getting that right? Where you say, look, if my computer tells me I can lightweight it this way, I better make sure I can fabricate it.
There's a lot of tools to do that. And again, because of the physics that's available, a lot of those tools are pretty strong. A lot of the CAM tools that are available. And a lot of the shops do understand how that works. Where the Industry 4.0 digital twins are getting into is they're getting more into the probabilistic, the random behaviors. How do I flow stuff through my shop due to random cycle times and things breaking and things changing and people doing different stuff and things I just can't model. And so that's a lot where the current, when you say digital twin, the current noise about digital twin is surrounding the more probabilistic systems. And so you may have a bottleneck system that you can't totally control. And maybe you can model a small subsection of your shop to understand flow behaviors to make improvements.
You know, I just want to piggyback on that. You know, I have a real live example of that. At one point, many years ago, we tried to apply a digital twin to the mortgage process. And the mortgage process is very complicated. You have to take an application, you got to underwrite it, you got to close it. And it was a complete disaster. And the reason it's a disaster, we just started too big. You know, we should have started small in one aspect, maybe taking an application, reducing application time, or, you know, one bottleneck. But we folks, it was too big too soon. And so my recommendation would be start small, learn about the technology, and then go from there.
Excellent.
So Tom, I just a little bit to add with the Bob that if we have the CAM tool with that CNC all kind of thing, you can do a demo run trying to see all combination, it's working or not, and then you can do the modeling and then you can testing. So it would be go step by step, smaller scale instead of jumping in, going around whole technology, and then you realize, oh, it did not work for you.
Yeah. So Suresh has been patient. And he had a question right up front. Says, can we pass on some costs of digital twin as a value-added benefit? Now we're getting into business model questions, but does anybody have maybe an idea on, have you seen this done where you create value add?
You don't build a twin if there's not value. I mean, build the twin for the twin's sake is just busy work, spending time and effort to do nothing. We're working on a senior design project with one of the tier ones right now, and they're building a digital twin of one of their systems, and the first thing we had to do was find the business case. Why are you doing this? What is the reason for building this twin? What is the purpose of this twin?
I would think, guys, that if you build a digital twin and it uncovers lots of areas to drive cost out of your process, that is the cost. You know, you have a competitive advantage because your process gets a lot more efficient very quickly because you understand through real-time feedback what is happening and then how to model simulations to correct that unwanted behavior or whatever is happening. Am I on track with that?
Well, yeah, that's back to the metal shop.
Yeah.
Find your pain point, focus on that, and you're doing it to solve a problem and add value.
Yeah, I mean, Tom, I've seen digital twins of assembly line processes, and manufacturers can get it in there. They can experiment with different layouts, different staffing levels, different equipment configurations. They can change it. So they don't have to be doing those changes in the physical world over and over again. I mean, there's huge value.
Oh, we're us muted.
So Tom, I'd like to just add a little bit. So while you are doing this digital twin, and that's, as you mentioned, that there will be a lot of learning that is value added, and there is no simulation or no digital twin. There is no business case. We're not just doing for sake of doing, though that company or that person got successful. We are doing, no, there must be a business case first for doing any simulation or any digital twin. That's the first thing.
Excellent, excellent. So there's another question coming in from Ravi, and this gets back to this machine problem, which is, he asks, how easy or difficult is it to make a digital twin of a complex machine like a servo-based packaging machine? If everybody can visualize this servo motor, probably multiple servo motors, packaging machine, and he's trying to model this, where would you start?
It really depends on what you want to do. I mean, are you looking to make a nice, pretty 3D model showing all the interactions and moving of the machine? Yeah, a lot of CAD work involved in interaction there. Are you just trying to calculate a flow through a machine? You can do a very rough kind of flow model. Again, you would design that system and the tools you'd use depending on what you want to do with that model.
Exactly, exactly. Anybody else have a comment on that? I guess maybe I'd ask it a different.
I would
Yeah,
say
go ahead,
something that's, first break it up, like make a whole flow diagram, trying to see what's value added, non-value added, and trying to spell out. And if you can understand the system better, and then slowly that, based on your understanding, and without understanding, don't jump onto to do it. So then you lay out the model and then try to slowly optimize and see how you can add value for this. Yes, it will be a very good project, and we did many bigger projects with the industry, with our student and myself, and easily we can do that kind of thing with the start with simulation, then make the twin, then compare, validation, and you have to do a lot of statistical validation before moving forward one step. So that kind of thing, because without validation, we start going. So sometimes you can say, we build the model, validate it, but you have to have the statistical validation to make sure that's we are not getting result randomly, or it is not part of the outlier, or whatever the improvement we are looking for. So I think it's doable.
Yeah, I think it gets back to asking, what am I unhappy about with this packaging machine? what is it?
Right.
Where am I deficient in terms of what I'm trying to understand? And it causes me pain every day or every other day. You know, if it's causing me pain once a month, you probably don't need to digital twin it. You probably need to put a sensor that tells you some bit of information, perhaps to your phone or something, right? And allows you to act. You know, you don't have to build huge churches for 1 hour Sunday service when you have to understand what you're trying to do. So I get where you're going with this. We have a lot of questions coming in, so let me keep going. This is fun. We'll make sure we'll try and answer our audience's questions. So Christoph asked, can you please describe the steps on how to get a true digital twin of a physical product? Or what, in addition to the known PLM solutions out there, has to be considered? So everybody's PLM expert here. What has to be considered to go beyond that to get to what we would quote unquote call digital twin?
So here I jump in because I would focus more on integrated system. If we say for the conceptual design, system identification, requirement, then we are going to design, initial design, then we are going to do the manufacturing, validation, testing, pre-production, production, all those things. And you can see there is a huge learning opportunity part of the PLM, product lifecycle management. That's the learning experience we are not gathering. So we are having pieces by pieces. You can say, I mentioned from the conceptual to pre-production to production. Every place is like you have the 20 models you are running for the same companies, but how do we capture the knowledge and use for the next one? So you don't do repeat the same thing again and again. So you can save time, you can save money, and you can bring the product earlier. So that kind of thing is still in early stage. That's whole part that I mentioned, integrated system from the conceptual design, all how the learning coming from each model or each year to next year, those kind of things still we are in very shaky stage.
Yeah. So anybody had a follow up on that? Because I have another question. Ravi helped clarify the question. I think will be a great way to get into a little deeper dialogue. So he says, what I meant was vibration analysis can't predict the failure of all the components on this packaging machine because breakdown is such a huge time loss, time is money, such a huge money problem. How do I build a digital twin that can help me predict failure on this machine? So I got these servo motors running, and so I'll leave it to you guys. Any ideas on that? Where you might start?
During my PhD study in Milwaukee in 2001 area, so I work with intelligent maintenance system. My advisor, Dr. J. Lee, and he had the NSF Center. So his main purpose was having the predictive model, degradation model. Now, so vibration is the one factor. So you need to identify, is this vibration is the critical factor, or temperature is the critical factor, or speed is the critical factor? All kind of things, or quality of the oil, the lubricant is the critical factor. So you identify critical factor for critical aspect, and you model, you analyze the behavior, and if you come up with the scientific pattern, and it could be the simple AI or simple prediction, simple time series model. So you have to identify, which variable is the critical for horse performance you are looking for, and then you model it, and you cannot do all in vibration. So you have to identify what's this. And if you model it, sometimes you can put as embedded system, and that you can put part of the whole digital twin. So embedded system it could build. And there are a lot of information available from NSF Center and other things. And I do also a lot of publication that area. So I think that kind of thing is the really scientific study you need to do. And
I think, guys, what you would do is, so as an example, and AMHUB, that was a great answer. If you started to put sensors on all the components that move, think of, a pneumatic cylinder, and you say, boy, when I digital twin that, I know that cylinder takes 100 milliseconds to go out. And all of a sudden it's drifting to 105, 106. It's not broken. It's still within, we're making good product, but it's starting to drift. I find that in a lot of these machines, long before the component fails, it starts to behave a little differently than what you have measured in the past. And that is a tell, right? Is that like one of the things about digital twinning is, look, if I'm running a twin and all of a sudden the physical system starts to behave differently, even though it's still performing fine, isn't that my tell, guys?
So Tom, I like to say this example is like our health. You can see our blood pressure, our sugar level, our heartbeat, all kind of things. When we see we get abnormal, we go doctor does all kind of tests trying to find what are the root causes, and they're trying to, if there is any threshold, like we got a degradation rate. If we say 90% degradation, 80% degradation, 70%, when we should kick off and then repair it. And same thing for our health. So we'll see. And
you look and act healthy, but your heart rate is up, right? You'd say, hey, wait a minute, my heart is beating too fast. Something's not right here. So Robert, you're going to say something too.
Go ahead.
Yeah, that is one of the use cases for a twin would be if you can build and verify the twin, which is the concept of Six Sigma. You know what the system should do, and you're comparing it to what the system is doing and then give you warning flags. In fact, that was kind of one of the things we were doing in the 90s of trying to build the digital twin for an OEM. They wanted that for a quote unquote dashboard. To kind of flag early problems.
Ross, any comments?
Yeah, I mean, the only thing I would say is that, if you're noticing, I mean, you got to make sure that what you're looking at is statistically significant, right? You can't just see something occurring and conclude that that's why a machine may be breaking down. You got to look at it with statistical significance. And that goes back to the Six Sigma comment that Dr. Van Til made, is that, you got to be careful of those judgments, but it's certainly something you need to look at.
Yeah.
That's what
Yeah, I mean, you either investigate a problem or you choose not to, and either answer will be borne out in fact eventually, and that becomes part of your learning. Says, I should have paid attention to that and I didn't, and I went down this rabbit hole and I should not have paid attention to that because that's a false indicator, right? That's the learning, right? You can't cheat and just go fast forward. You have to learn in this whole process.
That's
right?
Exactly right. And when I find when you're approaching a problem, you got to peel back the layers of the onion, right? And go deep on those problems. So, that would be my comment.
Yeah. So any downside to digital twins, guys?
Spending a lot of time and a lot of money to make a fancy thing that doesn't have value add. Focus on the problem, design the twin to solve the problem.
So
Great advice. Perfect.
people do a lot of planning, less execution. That's the serious thing. That you can do a lot of planning. So make sure your execution or implementation is perfect. So otherwise, you will not see the value.
Yeah, the salesperson can't design your system. You have to design your. You have to know what you want and then evaluate systems based
Sure.
on what you want, right? Because that's a disaster, and that happens all the time. They say, "Look, I don't have time to learn this. I don't have time to get in the bowels of this. I'm going to bring in 3 vendors. I'm going to listen to their pitches, and I'm going to pick the one I think fits." And you say, "But that's their best day. You are a prospect and not a customer."
Sure.
So you need to make sure
So
that.
just that in the lean manufacturing on Six Sigma, you can do a lot of planning, and there is one stage is the execution, manufacturing execution system. If you are perfect or close to perfect execution, manufacturing execution, you are the winner of the game.
Yeah. You can start to use the twin to solve the problem and then create value for the next problem. I mean, you can build a small twin of a small subsection of your shop and solve some issues in that. And now you have that available to, oh, well, if I add this other section of my shop and see the interconnections, now I can start to solve this other bigger problem. And so you don't build the big twin and then look at the whole system. You build small ones and you kind of grow out from there and you solve bigger and bigger problems. You get more value from it.
I think just to conclude, you got to be thoughtful as to how you're going to implement it. Thoughtfulness, I think, is really key if you want to be successful.
So last question, guys. Unfortunately, we got still more questions coming in. We've run out of time. But the last question for all 3 of you is, where is digital twin going? Put on your Karnak hats and hold the envelope up to your forehead. I know I'm dating myself. And try and give us a prediction of what do you think is going to happen to digital twinning over the next 3, 4, 5 years. And we'll start with Ross and go right down and finish with Ahad.
Sure. So I have some statistics for you. Listen, I don't think digital twin's going anywhere. It's going to proliferate. And I just have a few statistics for you. The Industrial Data Corporation forecasts within 5 years, 70% of manufacturers will be using digital twins to conduct simulation, 70%. They also predict that by 2022, those manufacturers using digital twins will be in a position to reduce equipment failures by 30%. The market's going from 3.8 billion to 35.8 billion by 2025. And so digital twin isn't going anywhere. There's going to be a lot of different uses for it. These technologies are going to advance. They're going to make it even more powerful. And so, the bottom line is I think people need to kind of focus on it, get on board, get educated about it, and continue to be thoughtful as to how they can use it within their organization.
I see AI as being the next game changer. The models existed, first game changer, IoT. Now we got the data. Now we can do stuff and build these models. And as IoT matures, it'll start making it easier to build these models and input the data and collect it and analyze it. And also it'll be able to start doing some analysis on what if and, hey, I got this model that represents reality. Where could this system go? And do some pretty advanced analysis on where you should go with the system.
Excellent, Robert. Ahad.
So I would say that digital twin will go toward more global supply chain level. So many suppliers, they would be using through the distributed computing system. Then industry would be coming with the different kind of standards of how to deal with industries and IoT, AI. And I would say that those companies could come up with some of the smaller packages for small and mid-sized companies that would be seeing. So that's because people are seeing, industries are seeing the benefit of the digital twin, and that's kind of thing. And normally simulation does a lot of horizontal integration. Now digital twin will do a lot of vertical integration. That part is missing in the part of the simulation and digital twin. So we could see a lot of vertical integration, not just one level integration.
Yeah, and I would say watch the cloud, because when you have AI and the cloud, all I need to do is have the data, because there will be companies that say, once I write the algorithm to solve this problem, I can rent you that algorithm for a couple seconds and give you your answer. And we may not even know each other. and here's your answer. So, you think that could be done for possibly pennies in the future, as opposed to hundreds of thousands of dollars. You feed them their data, they run their AI algorithm, they give you an answer, and you don't have a whole system built. You just have sensors and data. And that's your core value. So guys, this was fantastic discussion. One of the most lively discussions we've had, and it's wonderful that we're ending on that note. because, you know, right after we end this call, Bob and AMHUB and Ross got to get back to writing 2021's report. so they're back to work, everybody.
I got the email last night.
Yes, we're not kidding, people. This is it takes us a year to get this done.
Tom, thank you so much for you and for Automation Alley for leading this report, and thanks Bob from the Oakland University and Ross for all the help for this digital twin. And I'd like to mention our Associate Dean, Dr. Ellen Jensen, and we got all the support from Lawrence Tech. So we like to acknowledge their support for this digital twin initiative. And again, thank you, Tom.
Yes, thank you.
You're welcome, guys. You're welcome, guys. It's been a great ride. Thank you. More to come. So, thank you for joining us, all of you, Ross and Bob and AMHUB. For our viewers today, thank you so much for tuning into this live stream series. It's been a lot of fun. We've never done it before, and I'll tell you, we're going to continue to do this going forward because it's been great, a great way to get deep dive with our experts every week on a different topic. So really been fun. If you missed any of the previous episodes in this series or would like to rewatch any of them, they're all available on our website at automationalley.com/tech reveal. And our 2020 Technology and Industry Report is available on our website for download as well as I'll make sure the 2019 is somewhere where you can find it because we do reference that in this conversation quite a bit. Thanks, everyone. Have a great day. We'll see you soon.
Thank you.
Take care.
Thank you.
Bye-bye, guys.